Can an airplane be a helicopter? And vice versa? For many years these questions gave rise to disputes and ideas, and the answer to them was the first of its kind unique device that became the intersection of two worlds. Its history is full of victories and tragedies, political squabbles, military scandals, and amazing technical solutions. Hello aviators, Sky here, and I'd like to present to you a tiltrotor aircraft. Standing before us today is the V-22 Osprey. Despite the fact that the V-22 is a rather young machine, the history of its breed began a long time ago. The first full-fledged device using the tiltrotor scheme was the Bell XV-3, born back in the 1950s. The prototype did its job, giving a huge amount of data, but it did not reach the series. The technologies were still underdeveloped at that time. However, work on tiltrotors continued. In the early 1970s, a new research program was initiated, in which Bell Helicopter and Boeing Vertol competed. The Bell Model 301, retaining the overall layout of the XV-3, received a different powerplant, composed of two turboshaft engines directly connected to gearboxes and rotors inside the fully rotary nacelles. The Boeing Model 222 also received turboshafts in the tips, but unlike the 301st, they themselves were fixed, and only the rotors could turn. Years later, already in our time, we can see that both layouts saw the sky, and the Boeing version now seems even more promising. But then, in the 1970s, the Bell project won the tender. The prototype, called the Bell XV-15, was very good. Unlike the XV-3, which could fly, the new device showed itself perfectly. The technology had finally matured. The elegant machine was well controlled and could accelerate to speeds up to 332 knots, 615 km per hour, the level of a good turboprop plane. Aviators even built up the courage to show their work to the public at the Paris Air Show in 1981, where everyone was delighted with the outlandish thing. While the sky of California was being explored by an unusual aircraft, the Islamic Revolution took place in Iran, and the armed group of revolutionaries seized the US Embassy. The epic of saving diplomats had begun. The military had developed Operation Eagle Claw, the complexity of which is frightening even with a brief description. From the Nimitz aircraft carrier in the Persian Gulf, 8 RH-53D Sea Stallion helicopters were supposed to take off and reach the desert area southeast of Tehran. In parallel, 6 C-130 planes with equipment, fuel, Delta and Ranger squads were supposed to fly to the same place. The arriving helicopters were supposed to refuel and deliver them closer to the capital, where, after disembarking, the special forces were supposed to rescue the hostages and, under the cover of aviation, get to the city stadium, from where on the helicopters that came to the rescue, fly to a pre-captured airfield and leave the country on the arriving C-141 Starlifters. There is a feeling that the plan was written by Michael Bay, but for all the adventurism it was approved. And of course, it failed, more so at the very beginning. A sandstorm raged in Iran, which the planes flew over from above, and the helicopters had to break through. The result of a long and painful flight was that out of 8 machines, 6 reached the assembly point, of which 1 broke down immediately after landing. With 5 machines, the operation was impossible, and it was cancelled. One could shrug and say that at least there were no losses, but during the evacuation, one of the helicopters hit a nearby EC-130. Both machines and 8 people were lost. Running out of time, the military flew away on planes, leaving helicopters and equipment behind. Operation Eagle Claw was a terrible failure, followed by a gigantic scandal and costing President Carter his post. That same operation forced the military to think seriously about the technical aspects, and their stern gaze was directed first of all to helicopters. And the problem was not that they were somehow particularly bad. The problem was conceptual. The CH-53 cannot fly as fast, high, and far as an airplane because it is not an airplane. And you can't abandon them either. The C-130 of course can do short takeoffs and landings, but not short enough. They suddenly are not helicopters. The result of reflections and scandals was the only conclusion. something else is needed, combining the capabilities of both. What could that be? In 1981, the Joint Services Advanced Vertical Lift, or JVX program was initiated, which was supposed to give the military a transport that meets the new requirements. The US Army initiated the project, but the Marine Corps soon joined in, followed by the Navy and Air Force. The concept of tiltrotors seemed very tempting. The announced tender was attended by Grumman, Lockheed, Boeing, Bell, and even overseas friends from Aerospatiale and Westland. Considering how much experience Bell had in this area, their winning the tender was obvious, especially since Boeing soon joined them. In 1983, they received the contract. Considering that the new aircraft was largely based on the XV-15, its creation was carried out quite quickly. In 1985, the brainchild of the JVX program finally received the index, V-22, and the name, Osprey, after a species of birds of prey.
The Bell Boeing tiltrotor team, its hundreds of suppliers, and Allison Gas Turbine Division of General Motors proudly present to you and to the world the aircraft that will take flight to a new dimension, the V-22 Osprey.
In May 1988, the V-22 went through a rollout ceremony, making its first public appearance. Already at this pompous presentation, many high-ranking guests hid anxiety behind smiles. There were many successes, but no fewer problems. The further the program went, the more clear it became how expensive the tiltrotor would be to manufacture and operate. This problem led to the fact that the US Army, which was at the initial stage the main customer, actually withdrew from the program, deciding to direct budgets to modernize the helicopter fleet. This decision seriously cut the portfolio of orders, and the reduction in mass production, yes, made the machine even more expensive. Washington was buzzing, and curiously, the Pentagon was rather skeptical of the program, while Congress, on the contrary, actively supported it. So, before us is the V-22 Osprey, a convertiplane, so its description will be similar to both an airplane and a helicopter. Its overall layout is reminiscent of Bell's predecessors, the XV-3 and XV-15. The fuselage is more similar to the fuselage of a light military transport airplane, with a raised tail section, a ramp, and twin tail. In the lower part there are large fairings, inside which equipment is placed, some of the fuel tanks, and niches for the main landing gear. The gear is tricycle reinforced with a front swivel leg. All bogies are two-wheeled. The V-22 is a high-wing aircraft. The small span straight wing received two sections of large flaperons on each side, which act as ailerons and flaps. At the wingtips in the rotary nacelles are engines and propellers. In terms of materials, the engineers did not rush to the forefront, although the battle for mass forced them to try. About 43% of the structure is made of composites. Due to this, the dry weight of the tiltrotor is 14.4 tons, and the maximum vertical takeoff weight is 23.8 tons. When taking off with a run in STOVL mode, the lift of the wing allowed it to be heavier. The mass here increased to 27.5 tons. Length 17.5 meters. Not much, in fact a little longer than the Black Hawk. Although many people think the V-22 is a huge machine. The wingspan is almost 14 meters, and if you add rotors to them, the total span of the V-22 will reach 25.8 meters, which is already more than the dimensions of the very hefty CH-53E. The height of the machine is average, with tail tips at 5.4 meters and rotor tips at 6.7 meters, something between the UH-60 and CH-53. Considering that the V-22 was made primarily for ships, whose hangars are limited in volume, the size problem was quite significant. The usual folding of the rotors was not enough here, the wing was still large, so the aircraft, having folded the blades, also folds the wing, or more precisely turns it into position along the fuselage. The length of the machine grows, but the span decreases to 5.6 meters. This operation is simple and takes, on average, 1.5 minutes. The V-22 uses the fly-by-wire control system. The onboard computer is very advanced. It performs both the usual autopilot functions and special ones, such as switching from mode to mode or acceleration and deceleration, practically without the participation of pilots. Considering how many processes have to be controlled at once, it would be extremely difficult to pilot without such automation. The aircraft has a glass cockpit, equipped with 5 large multi-function displays, 4 standard and 1 special, capable of showing, for example, an image from external observation devices. Crew 3 to 4 people, 2 pilots, a flight engineer, plus 1 more person who performs additional functions, for example a cargo or weapons operator. The cabin of the V-22 is quite spacious, capable of accommodating 32 people, 22 fully equipped soldiers, up to 9 tons of cargo inside, light military vehicles, or 5.7 tons of cargo on an external sling. Loading on board is carried out through a lowering ramp in the tail, as well as through a door in the forward part of the fuselage on the starboard side. Given the average flight altitudes, the cabin is not pressurized, so at an altitude of more than 3 kilometers, it is recommended that the crew and passengers wear oxygen masks. With weapons, it was quite difficult. During the military missions, transport helicopters usually operate under the cover of attack vehicles. The V-22, given its speed and range, allows for the possibility of independent missions, which requires extraordinary solutions. At the base, like helicopters, it is equipped with the M240 or M2 machine guns. But with extra weapons, a lot of ideas arose. It is proposed to install a GAU-19 3-barrel rotary heavy machine gun in the bow. You can put a remotely controlled IDWS, Interim Defense Weapons System turret, under the belly, and of course hang on the machine a bunch of different missiles and bombs, like Hellfires and GBU-53B. The military is in no hurry with these decisions. It makes no sense to turn the V-22 into Apache, and all these killers are expensive and add extra weight. The V-22 powerplant is something beautiful but complicated. 2 large turboshaft engines, together with gearboxes and rotors, are connected inside single pods, which in turn are mounted on the wingtips and can turn in the range from 0 degrees horizontally to 97.5 degrees upward and slightly back. The rotation can take any angle within these limits, so a takeoff run is often practiced with increased takeoff weight and a turn of 45 degrees, or the so-called 80 jump, a quick takeoff run at an 80 degrees angle. The mechanism is quite nimble. It is able to rotate the nacelle 90 degrees in just 12 seconds. There is also a safety net. The engines, with the help of drives and shafts passing through the wing, are synchronized, and if one engine fails, the second one will rotate its propeller too, keeping the machine in the air for some time. Similar solutions are used on helicopters with multiple rotors. The rotors of the V-22 immediately catch the eye. 2 propellers equipped with 3 hefty rigid blades and mechanisms hidden under large fairings. Clean, aerodynamic, beautiful. However, the requirements for work in both airplane and helicopter modes, as well as compactness for placement in ship hangars, required compromises. The diameter of each rotor is about 11.6 meters, and while that's a lot for an airplane, it's small for a helicopter. Not critical, but the disc loading is quite high. Now to the engines. Inside the nacelles are the Rolls-Royce T406 turboshaft engines, also known as AE1107. Here, patriots may be outraged why one of the symbols of the US Armed Forces flies on non-American engines. But in fact, the engines are American, the brainchild of Allison Engine. Just in the mid-1990s, the company owned by General Motors was sold to Rolls-Royce, and is now known as Rolls-Royce North America. The engine is very serious. It has 5,890 horsepower in cruise mode and up to 6,150 horsepower on takeoff. 6,150. Just so you know, the CH-53E, the huge super stallion, has 4,380 horsepower engines. Someone at Bell is very interested in muscle cars. Why so much power? It's a combination of factors. The design of the V-22 powerplant is sleek but complex, and all those extra drives eat up some of the power. In addition, the lifting force of the rotors, due to their scarce size and wing washing, is not very large. Additional power is needed. And we also shouldn't forget about progress. The engine builders managed to add power while maintaining fuel efficiency and reliability, and horsepower is never excessive for military vehicles. The CH-53E, for example, flies on 4,380 horsepower engines, and its successor, the CH-53K King Stallion, already flies on 7,500 horsepower monsters, so no need to be surprised. Everyone is now a fan of muscle cars. And that is not all. As part of the upgrades, Rolls-Royce brought the power of their fiery hearts up to 8,800 horsepower, and in the future, they promised to boost it up to 10,000 horsepower. As I understand it, they want to make the V-22 supersonic. This power is felt not only on board, but also on the ground. An unexpected problem. Osprey is windy. On takeoffs and landings, it creates around itself entire hurricanes. The V-22 is equipped to perform aerial refueling, but this practice is fairly common. More interesting is another option, when the V-22 is the tanker itself. The appearance of the F-35B fighters on amphibious assault ships seriously strengthened them, but also brought the problem of how to provide them with aerial refueling. On conventional aircraft carriers, this work is done by aircraft that you can't put on an amphibious ship, and helicopters are too slow for such work. It turned out that the fighters appeared, but remained tied to ground airfields or large aircraft carriers. Boeing suggested using the V-22, and as part of the tests, the modified tiltrotor successfully refueled the FA-18. This practice is not yet applied massively, but technically, everything is already there.
Still looks good.
All right, I'm barely off the ground at 60 torque.
The first V-22 made its maiden flight in March 1989. There were 6 prototypes in total, and they were tested, in fact, during the entire 1990s. The crews and technical staff of both companies and the military worked on them. During the tests at sea, the machine performed very well, working on assault ships and aircraft carriers. The only nuance was that, as it turned out, the hot exhaust of the engines on takeoffs and landings burns the deck. But here the ball is already on the side of the shipbuilders. They will have to make their decks more heat resistant, especially since, firstly, the problem is not new, and secondly, next to the V-22, F-35Bs take off and land from the same decks, and it is unlikely that jets from their engines are colder. The method of training the crews ended up interesting. As it turned out, people, before working on the V-22, have to be trained both in helicopters and on airplanes. Moreover, disputes do not stop on which initial experience is better, plane or helicopter. Meanwhile, the machine is quite comfortable. The pilots of the V-22 note that in level flight, it resembles the C-130. The classic Osprey flight pattern, like other tiltrotor aircraft, is simple. It takes off and lands like a helicopter, with rotors pointing upwards. After takeoff and a little acceleration, the tiltrotor tilts, turns the rotors forward and goes into level flight like an airplane, when lift is created by the wing and the engines are responsible for thrust. The problem of the speed limit for helicopters is practically resolved. Besides, such a flight is much more economical, which allows it to increase the range. This gives the flight performance that the military dreamed of, a maximum speed of 266 knots with a limit of 305 knots, a service ceiling of 7,620 meters, close to turboprop performance. In addition, one more indicator, usually hardly noticeable next to speed records, but perhaps even more important. The flight range with a normal load is almost 1,600 kilometers, which is several times farther than conventional helicopters, and this is not including aerial refueling. With these parameters, if in the Eagle Claw operation Ospreys flew into the mission instead of Sea Stallions, neither Sandstorm nor range would have been a problem. The operation most likely would have failed anyway. Well, honestly, there was risk on every step, but at least the first stages of the plan would have been easier to implement. Despite the fact that in general the machines showed good results, there were many bottlenecks. They were difficult to maintain, heavy, and demanding in piloting. Moreover, while most of the problems were solved over time, some remained conceptual. As it turned out, the V-22 is both a plane and a helicopter in flight, but during an emergency landing it is neither a plane nor a helicopter. Its layout impairs helicopter auto-rotation capabilities in case of engine failure. It is possible to glide like an airplane for some time, but again, a normal horizontal landing is difficult. At least when you meet the ground, you can say goodbye to rotors pointing forward. The engineers took many measures to prevent emergency landings. The engines were synchronized, the systems were duplicated, and the structure was reinforced so that it could withstand a fall from a big height. But still, this issue cannot be called completely resolved. Also, during flight tests, there were many incidents, some of which ended in disasters. In 1991 and 1992, 2 prototypes were lost, and while one crashed during tests and miraculously without casualties, the second crashed into the Potomac River during a demonstration flight, killing the entire crew in front of military officials. The darkest year was 2000, when one machine hit a vortex ring upon landing and fell, and the second, due to a control failure, collapsed into a forest. 2 disasters claimed the life of 23 people, crews and Marines. The whole program was hanging in the balance again. It was criticized from all sides, and even the Marine Corps, having lost so many of its people, began to hesitate in the issue of its support. The training program was revised. The pilots had to know their machines in great detail, intuitively understanding many, often not obvious nuances of tiltrotor aircraft control. In parallel, Bell and Boeing had to work hard to ensure that any technical aspects of the disasters were eliminated. And in principle, the problem was solved. Now the V-22s are quite in line with military standards in terms of safety, but the nuances of operation and reputational damage from disasters are still felt. Many still believe that Osprey and tiltrotors in general are an expensive and extreme sport, and without special need, it is better not to show off and fly on ordinary helicopters. This, to a large extent, was the reason why the modified MV-22, proposed as the presidential Marine One, gave way to the VH-92 Patriot, a classic helicopter. POTUS decided to ride on something less avant-garde for the time being. But the main problem was still the cost. The V-22 is very expensive. From initiation to adoption, the military spent $27 billion on it. In the early stages of serial production in the early 2000s, one tiltrotor cost more than $67 million, not including development costs, which is almost twice as much as the CH-53E, and the cost of its operation turned out to be more than 60% higher than what was originally planned. In fairness, it should be noted that optimization and implementation of improvements have reduced these figures, but they are still far from the level of helicopters, even large ones. This was the reason for the stretching of delivery times. Customers simply could not afford to buy the machines in the originally planned quantities. Establishing production for Bell and Boeing was a serious challenge, as a completely new machine of an unusual layout required a major modification of the factories. The work was divided approximately equally. Boeing handled the fuselage, cockpit and avionics, while Bell created the wing, tail, powerplant, and also performed final assembly. Serial production began in 2005. The initial pace was very modest, only about a dozen a year, but by 2012 this figure had reached 48. In total, the military ordered 458 vehicles, 360 for the Marines, 50 for the Air Force, and 48 for the Navy. Tiltrotors are being improved to this day. Fortunately, there is room to grow there. In the early 2010s, after receiving data on serial operation in the military, Bell and Boeing carried out large-scale modernization work. Onboard systems and some structural elements have undergone improvements. The main result of this work was the appearance of the V-22C version, with improved flight performance, a new radar, optimized controls, and electronic warfare systems. The The companies also paid a lot of attention to optimizing production to reduce costs and developing a maintenance information system, something like the ALIS or Odin systems that Lockheed Martin makes for the F-35. The launch customer of the tiltrotor was the US Marine Corps, which received its first Osprey with the V-22 index in 2005. High-speed and long-range tiltrotors were an important tool for them, as they made it possible to carry out combat operations from assault ships from a safe distance. New machines actively replaced the CH-46, and this process was completed by 2014. They were baptized by fire already in 2007 in Iraq and in 2009 in Afghanistan. For the most part, they were engaged in the transportation of goods and authorities, but in military operations they were also periodically used, quite successfully. The military was very pleased, the performance was impressive, and the problems arose mainly at the maintenance stage, which was not yet sufficiently established. In 2006, tiltrotors of the CV-22 version entered service with the US Air Force, where they began to work in the interests of the US SOCOM, Special Operations Command. The CV-22 features a large fuel capacity, terrain-following radar, additional surveillance, and defense equipment. Considering the specifics of the place of work, not much is known about the service of these machines. One notable operation in which they were used was the evacuation of Americans from South Sudan in 2013. Not very successful. The tiltrotors, after a long flight, approaching the evacuation zone, came under intense fire and were forced to withdraw from the battle. However, after hundreds of hits, massive damage, and wounding of several crew members, the tiltrotors remained in the air, proving their durability. Later, for additional protection of people on board, composite bulletproof armor was developed. It is removable. With a weight of 360 kilograms, no one wanted to carry it around all the time. The history of communication between the Osprey and the US Navy was complex and full of drama. At the beginning, the sailors favored the JVX program and wanted to take versions of the HV-22 to perform search and rescue missions and transport troops. But after a while they cooled off to the machine and preferred to purchase the MH-60S. In 2009, a new role was invented for the tiltrotor: carrier onboard delivery. Sometimes the ships of the fleet are at great distances from each other and from the bases, and the range of helicopters is not enough. Therefore, for a long time, this work was taken over by aircraft like the C-2 Greyhound, but they could only work on aircraft carriers. A tiltrotor, on the other hand, can fly far and deliver cargo to any ships, and not only ships. So, the CMV-22B was born. Bell and Boeing received an order for 48 aircraft, some of which have already been delivered. So far, the only non-American Osprey operator is the Japanese Self-Defense Forces. In 2014, the Japanese ordered 17 MV-22B. They are deployed on boards of the Izumo-class flat-deck destroyers. No more machines have been exported so far. India, Israel, and Indonesia show a certain interest in them, but for now without deliveries. As of the early 2020s, more than 400 V-22s have already been built. The figure is not huge, but the machine is specific and expensive. It was obvious from the very beginning that gigantic deliveries were not to be expected. However, these 400 aircraft are in active service and have already flown more than 600,000 hours in interesting, difficult, and dangerous places. The V-22 Osprey is not simple. It cannot be called an unconditional success, it has many problems, but the bonuses it gives are impressive. The concept, having overcome decades of trials and several large aviation programs, reached the production model and proved its worth. The V-22 is certainly a unique aircraft that gave rise to a special breed that is still in its infancy: tiltrotors. Now, other similar vehicles are taking to the skies, both military and civilian. On this, I think, it's time to complete the story of the V-22, but not tiltrotors. Like and subscribe to the channel, and if you want to watch the videos early, see some exclusive behind-the-scenes content, or just support the channel, consider joining our Patreon community. fast flights, vertical takeoffs, and soft landings to you.